Good day and welcome to another video on this YouTube channel. I still remain your host Abasolaya, and today I'll be teaching someone matplotlib, and that's majorly on data visualization with Python. And I hope you enjoyed this tutorial because it's going to be an interesting one. So, okay, matplotlib basically is like I know they even call him grandfather, and they call him the great grandfather of visualization in Python. Okay, all this history you feel read them yourself. No, just jump enter the actual thing. So basically, we okay. If you don't get matplotlib for your system, as in if you don't have matplotlib, you can actually pip install matplotlib or conda install matplotlib. You are using Anaconda, but the thing is, if you are using the latest Anaconda, it automatically comes with matplotlib, so you don't need to disturb your head with installing matplotlib. So you just import matplotlib as plt here. matplotlib.pyplot as plt. Actually, there was this thing I saw recently. The guy just disorganized. I will send it to you on WhatsApp. The guy disorganized the arrangement. He imported TensorFlow as plt, imported NumPy as tf, imported pandas as something else. Yeah, I imported everything jaku like that.
And it worked.
It will work, but it will confuse you because you are already used to plt for matplotlib and the likes like that. So the thing was, they will now put Devil's picture beside him. Devil come talk say, "Guy, I respect you." Like Devil said, fear me. So okay, maybe we just go on. So this one is just to have our plot show in line, like it should show immediately underneath it. But if you are doing it outside Anaconda, maybe you are using your PyCharm or Spider or something like that, you have to do plt.show at the end of each plot so that you can see what you've plotted, because it no go show at all. But in line, this matplotlib in line here, we help us show it underneath it. But recently we don't really need this thing, because recently I forgotten to add this thing, and it still showed me my plot. So let's just do a basic example. Here we want to generate 11 numbers between 0 and 5. Then we are now using y to be equal to x raised to power 2. So for each number between 0 and 5, now we are raising it to power 2 for x. For
y. I don't get to. You wrote 0, 5, and 11. So
we are generating 11 numbers between 0 and 5. Okay, see. 0, 0.51, 1.52, 2.5, like that. So we generated 11 numbers between 0 and 5. Then we are now squaring each of those numbers here. Now what we're going to do here. So y equals square of each of those numbers. So if you notice, 0 became 0, 0.5 became 0.25, 1 became 1, 1.5 became 2.25, then 2 became 4, 2.5 became 6.25, 3 became 9, 3.5 became 12.25, 4 became 16, like that. So basic matplotlib command. So basically what we want to do here is we just want to plot. So the actual thing to plot is actually this thing. If you write just this one, in go plot. Okay, let me just copy it. Let me insert a cell above. Let me just copy it here, so I can show you. You see, say in plot wetin suppose plot. But the thing we are doing here now is after it plots, this R indicates that okay, make the line red. If I turn this one to B now, let me come back here. If I turn this one to B, it's supposed to change to blue. You can see change to blue. If I change it to G, you see change to green. So like the RGB colors. Let's see.
Sorry.
Thank you, Jerry. So see now, see change them to see cyan. So let's just change that back to red, because it be like that red pop out where. So coming down here now, so all this X label is just to label the X axis. That's this place. Then this Y label is just to label the Y axis. That's this place. Then this title is just to give it a title on top of it. Then plt.show. This one is when you are doing inside something like Spider or PyCharm. Now why would they add this one? But if you no add them for here, this thing go still show. You see I not add anything for here and it still show. So now waiting we just do for here, and you see it's actually working. You can see the Y axis label is here, the X axis label is here, then the title is here. You get them like that. So make I just move on like that. So now here we want to start creating canvas. So what we mean by canvas is, okay, maybe we want to have more than one plot in just one place. Like for example, number of rows you want to have, number of columns you want to have, then plot number. That is, okay, now let's say I want to plot 2 by 2 matrix. That is, I want to plot 4 this thing. Let's say this is the canvas now, and I want to plot 4 plots. So one go dey like this, like if na 2 by 2, so 2 on each, 2 on a row, 2 on a column. So 2 on a row will be like 1 2 1 2, 1 2, then 2 on a column will be like 1 2, so it come be 4. But here we said 1,2, that is we want one row, that is one row like this, then 2 columns. Then the first plot is this one, then second plot is this one. So that's n row, that's number of rows, n column, number of columns, then plot number, that is the position the plot we are doing is taking now. So for example, we want to plot this one now, we are doing r line. This one is, this dot is line, that is let me just plot it so that you can see. So you can see the dot line,
okay,
which is
so it will be like a dotted plot.
Exactly. Then this one is star. Star will indicate where the points are gone. You can see the 0 is here, 0.25 is here, the the 1 is here, no, 1 is here, the 1.2, 1.25 is here. Abi, what are the numbers? Make I check them for here again. So 2.25 there is here. So like that. So the star indicates the position, the points of this thing that we have here. All these points, the star indicates them. Then this one is just the dotted this thing. So that's that on that. So this one is just to give it the pattern the line will follow. So if I remove this one actually and I plot it again, you can see it's not having any star on top of it. If I add it back, it's having star. For example, if I remove this one too, you will see the line go turn solid line. You see a solid line. But if I undo it back, it's turned to dotted line. So that's that on that. So matplotlib object oriented method. So basically we can start creating, like, I don't know if you know object oriented programming. That's like creating classes.
OOP.
OOP, yes. OOP. Now which are they call them that? So now that we've seen basics, let's break it down with more formal introduction of matplotlib object oriented API. This means we can instantiate figures object and then call method to attribute from the object. So introduction of object oriented method. The main idea in using the more formal object oriented method is to create a figure object and then just call methods or attribute of that object. This approach is nicer when dealing with canvas that has multiple plots on it. To begin, we will create a figure instance, then we can add axis to that figure. Okay, for example, see now we created a figure here. It's something like instantiating something. So we instantiated like plt.figure. So we call it fig. So now whatever we do to that fig now, it's something like we are putting it on this plot now. So for example, axis fig.add axis. So we added this axis. So this is like the point on the axis. Then we came down here again and we said, okay, axis dot plot x comma y, then make the line color blue. Then we give it label. So set x label, y label, then title. So we run this now. You see, say our axis took 0.1, 0.1, 0.8, 0.8. Then we have left, bottom, width, height. So the left is 0.5. That's, where's my left hand? This is the left hand side, 0.1. Then the bottom is 0.5, 0.1. Then the width is 0.8, 0.8. Then the height is 0.8. So that's basically that on that. So, and you remember this one we had mentioned for here before, yeah, when we're doing x label, y label, and the likes. Majorly I don't really use this one though. This is the one I use, but this is the more formal one. Like if you want to look like you look bish, you know this your
which one
you want to oppress people. Now this one you go use if you want to oppress people, but the normal thing that I do is I use this one. So you can use this method too if you like. This one is just you need to instantiate, then you start working. That's the basics of that one. So code in this little more is a little more complicated, but the advantage is that now we have full control of where plot axes are placed and we can easily add more than one axis to the figure. Okay, for example, see now we instantiated again, then we gave it axis 1 equals this, axis 2 equals this. So we are putting axis 2 inside axis 1. That's basically what we are doing here. So you can see 0.2 is within this 0.1 and 0.1. Then 0.5 is within 0.1 and 0.8. 0.4 is within that range too. 0.3 is within that range too. So it's not like you are giving this thing a shape within another shape. So now the first plot is this one, the axis 1 is this one, then the axis 2 is this one. So this thing is just like giving your plot a geometry. So this one now is bigger than this one. So if you now plot this now, you notice, see the first plot is in here. I mean second plot there, this axis 2 is this one, then axis 1 is this one. Do you get it? No, don't say I know you don't get them.
I don't get that one. Come again.
I suppose ask question, I'm not talking, suppose talk say you don't get them. Okay, make I explain again. Okay, basically if I come back here, this thing we did here, something like we are giving it a geometry. So we are saying left, bottom, width, and then height. So we said, okay, left is this one, bottom is this one, width is this one, then height is this one. Like that. So it is just in between the range of 0 and 1. You can't go beyond 1. So you are just telling it the ratio it should take. Like the normal plot, okay, the normal plot should have something like this. Something like this. So you're now telling it, okay, I'm using this ratio on my plot. So now we now got here. The ratio we are now using now, you can see this ratio we are now using here is less than this one. Something like you are saying, you know, when we're using, you know, you did plotting in secondary school now, where you go use graph book.
Yeah.
So imagine your graph book now. This one started from 0.1 and ended on 0.8. Then the other plot started from 0.2 and ended on 0.5. You see, say that one goes small past this one, but they are on the same graph book.
Yeah.
I don't know if you get me well. They are on the same graph book. So now why we can't get this one now?
It's a bit complex too, though.
Okay.
So okay.
Ask your question.
Like, as this one that's it. Where's axis 1?
This axis 1.
Like is axis 1 not showing
the bigger one? The bigger plot is the axis 1.
But like, okay. You said the first one is left. Like, where is it showing on the plot that is left?
Left as in?
Okay, you said, okay, the point on that axis 1 is 0.1, 0.1, 0.8, 0.8. You said the first one, that 0.1 is left. Second 0.1 is right. Third one is width. Last one is height. So what I'm saying is that, like, that proportion, how is this showing on that graph on the plot?
Okay, how do I explain it now?
Do you get what I'm saying?
I get what you're saying. Okay, let's use your graph book as an example. Your graph book, the left is like, okay, when you count those boxes, you know our graph book is like 1 centimeter.
Yeah,
you have like
5 meters,
10 dots inside 1 centimeter.
Yeah.
Now imagine 0.1 is on that graph book. Then imagine 0.2 on that graph book too. No, you get to 0.1 before you get to 0.2 from the left.
Yes.
Now exact same thing will happen for here. So now like from the left here now, we get 0.1 here. You can't get 0.2 here. I don't know if you get them.
Yeah.
Then 0.5. 0.5 is what? Bottom. See now. We get 0.1 for this one. 0.1 got to this point. So you are counting from the bottom now. 0.1 got to this point. Then 0.5 is like after counting 1, you have to count 2, 3, 4, 5. I don't know if you get it. Now same thing with this one now. So we now have 0.8. 0.8 is the width. Abi? It's the width, yes. So 0.8 is like this width now. Like of that 1 centimeter now, we dey use 0.8 of the 1 centimeter. I don't know if you get it. Like we're using 80% of it. So, but this one is using 40% of it. Now why this one height? I mean this one width is less than this one.
Small, yeah.
But if you check this one, if you use ruler to measure it, actually this one is like half of this one because 0.8 and 0.4.
Yeah, half of each other. Yeah, I guess.
Then the height is 0.8, like 0.8 of the normal height. So 0.8 like this. Then this one is now 0.8.
So is it that we can change it from, let's say, 0.8 to maybe 1?
You can
change it, just make it bigger.
No, it's not.
Try
like
change more.
It's not like it will get bigger like that. You can see it like a little longer.
Yeah.
So you get them like that. So we'll continue, Abby. You get them now?
Yeah.
Okay, let's continue. Then subplot. Okay, basically what we are doing with subplot is something like what we did here. So plt.subplot. Then we have all this shenanigan. Then if I run this now, so it's something like, okay, plt except using tuple unpack graph figure axis. So this subplot, you understand it better as we move upwards. So you can see we created this thing. You can see number of columns that we want, number of rows. We have one row like this, then 2 columns, 1 2. You get it? So this one is just instantiating. We've not plotted. For example, here we instantiated and plotted immediately. Now why we just see the plot appear automatically, but here you see we just instantiated. Then we plot out the axis. It's just telling us the axis of the subplot. Then now if we now plot on those distance, now we can't dey plot on top arm. See now, axis dot plus x equals x comma y, then b. We are making our line blue, so we are plotting x comma y. So x on the x axis, y on the y axis. You know, x will come before y. So now what we do for here? So but now says same thing we plot on the two of them. So for axis in axis, now what we do for here? Ad being okay. If I get here and I say what do I do? If I say there's nothing I can really do. I wanted to change what will appear on both of them, but maybe we'll just leave them for now, because you can actually have different plots on each of them. So a common issue with matplotlib overlapping subplot is, subplot or figure is we cause fig tight layout or plt tight layout method, which automatically adjusts the position of the axis on the figure canvas, so there is no overlap content. So subplot, then this shenanigan, then we are saying plt dot tight underscore layout. You notice this one is going from this one, like we have more space between them so that they won't overlap each other. If you notice, this y is overlapping here. You know this y is for this one, not for this one. But if you look at it here, it's something like this y is now entering this split. So if you now put this tight layout now, something like you are telling it, oh, this thing is too tight, oh yeah, give it more space. So now then why you just put extra space in between the two of them. So fig size aspect ratio, though you can do all these things you are doing with your normal plt.plot, oh, we don't do them for here already. It's just you having to put number of rows, number of columns, then the position of the plot. But this one is quite more exaggerated. Like you can easily control what is happening. Now why would they use all this shenanigan? But I no go lie, I still know they use them. Now the first one I still they use. Maybe because I never advanced reach your level. So
the one also.
Okay, we don't instantiate again for here. So we can actually give our plot size. Now what will they do for here? So fig size equals 12,3. So if we run this one now, you notice, you see this one is 12, x axis is 12, this one is 3. Do you notice it?
That one is wider than
if I change this one to 3 now, and I change this one to, let's say, 12, if I run this one now, you see it can long. You get them?
Yeah.
Not the thing. So if I run this one back now, you see how the thing do. So that's on that. Then saving figure. So now what you they ask the other time, the way you were saving
the CSV file.
Data for a CSV file. So this one too, if you save your image, your plot, so you just use save.fig, fig.savefig. So once you do that one, you go just save for your desktop automatically. You know, so they share this thing for here. Now they share Chrome, but if I go back to my this thing now, it would have saved on my system automatically. So same thing here, but this one I'm just giving you a DPI, like how the thing will appear well. I wish I can show you that, but let me just, don't let me waste time. Let's continue, because I will have to close your stop sharing, then start sharing those ones. But when you try, I will send you this script so you can run it yourself and see how the thing will look. This DPI 200 will be better than this one. Now the only thing we did there be that. So then legend, label, and title. So title is like set title equals this. So now just like you are setting title for your axis. Then label. So set X label, set Y label. Now like when would they give X label and Y label the other time? So now it's when they give to this one now. So if you now plot this thing, all those things we don't do since all of them go appear. See now, X label, Y label. So it's now telling us, okay, this our X label is this. You can see, no, sorry. This one we're having more than one plot. Set X label, Y label. Okay, let's go on. We have more than one plot, then plot figure, then add axis. We've added our axis. You understand this add axis now? 0, 0,
Yeah.
1, 1. Like we are using the old thing. It's not like that one where we're using 0.1, 0.1, 0.8, 0.8. This one we are using the old thing. So here now we are now saying, okay, plot X, but this thing is the legend you give it is X raised power 2. Okay, that's the label here. But the actual thing it will plot is X comma X raised power 2. That is X comma X raised power 2. Something like 1 comma 1 raised power 2. That's 1, 1, 1. 0, 0 will be 0. 1, 1 will be 1. Then 2, 2 will be 2 comma 4. I don't know if you get it. Like, okay,
No.
You are not getting it. Okay, our X is like 1, 2, 3, 4. I don't know if you get it. The X will instantiate at the top here. Where is it? That line space that we instantiated here. This is our X here now. So what we are now telling it is, okay, now plot. Where is it again? Now what we want to plot is on the X axis, pick the X point. On the Y axis, pick X raised power 2. Then do that for the next one too. So it will be like 0 raised power 2 is 0. 0.5 raised power 2 is what? 0.25. So it will be 0.5 comma 0.25. Then the next one is 1. 1 raised power 2 is 1 comma 1. So it will be 1. Then 2 raised power 2 will be like 2 comma 4. Like that. Now why did the plot look like this? You see that the plot they rise. But it's harder for it to rise from the beginning. But when it gets to this thing, in the rise like Bitcoin, when it gets to this place, it's rising faster than the initial places. And if you notice the X raised power 3 goes higher than the X raised power 2. I don't know if you notice it.
Yeah.
Because X raised power 3 of course will be greater than X raised power 2. But the beginning was the same thing. Because the difference was very small. I don't know if you get it. The difference was very small in the beginning. Because 0 raised power 3 and 0 raised power 2 is still 0. Then 1 raised power 2 and 1 raised power 2 is still 1. Then when we get to 2, it's 2 raised power 2 is 4. 2 raised power 3 is 8. So now why the thing rise like this? This one come. So it's like let's say which Bitcoin if we compare like that. Dogecoin and Bitcoin. The two of them like this. So if we call
say you get crypto.
I know they do crypto. Na lie, they lie. I just get idea. If you give me money, make I invest for crypto, I go still do am. But I know people put my money for now. My money never reach that side. So now the legend function takes an optional keyword argument loc that can be used to specify where in the figure the legend is to be drawn and allow value of LOC numeric code for various places where legend can be drawn. You can check for the documentation with this link. For detail, some of the most common LOC values are here, and I go post it on my GitHub. So if you want check and if you go check out for my GitHub, sir. But I go still send this one to you, shall. So this one now, axis.legend, you can say location 1 up right corner, location 2 is left corner, location 3 is lower left corner, location 4 is lower right corner. So for example, our axis.legend here, we are saying location 0. So you can see location 0 is this place. So if I change it to location 1 now, let's change it to location 1. So you can see what I'm saying. Location 1, you can see location 1. If I change it to location 2, you can see location 2 return back to where it's supposed to be. Location 0 is actually the default. Location 3, you can see it came down. Location 4, it will now come down. If you come to this side, I can change it to location 4 now. So 4, you can see it came down here. So whichever location you want to put them, if you just change location yourself. But by default is 0. But if your plot can't be like, you know, this plot is like this, now why it make sense for here? I think your plot was mirror image of itself. Like this one is now like this. This one is now on this side, and this side is on this side. Then this one will make sense on this side rather than this side, like that. So let's keep going. Then setting colors, line width, and line type. So I've mentioned the line type the other time already. So line type is okay. This like color. This one is color. Then this one is line type. So blue line with dot, green dash line. Now waiting the years down. So let me just read what is here. With matplotlib we can define the color of lines and other graphic elements in a number of ways. First of all, we can use the matplotlib line syntax where B means blue, G means green, and like that. So we can have blue, we can have green. I told you the other time that we can have red, we can have cyan. Like, okay, let me just give you this thing. Let me just come up here. Let me comment it. So we can have RGB. Then we can have, I forgot the name they call the other one, CMY Kinecon. That's cyan, magenta, yellow. I forgot the name of the last one. So we can actually change all these things to all those colors. For example, if I plot this one now.
Say color of the rainbow.
You can use all those colors of rainbow. So you can see this one is green and this one is blue. If I change this one now to, let's say, red, you know, it's now red. I change this one to cyan. You can see we don't get them like that. Then we can change it to magenta. You can change this one to yellow. You can see it in one like that. But make I just return that back to the default. So like that. So make I just run them like that. So going on from there, then we have color with color equals parameter. So basically what we are doing here is, okay, we want to start using hash color code. All this is hash color code, but me I know the cram, but you can Google it, yeah. If you go to, let's say, then you can say hash colors. Let's just do hash colors. You see which one they search now?
Yeah, you get website. You get website.
Website as in?
I dey see Phibitech for here now.
Phibitech. I get website. I get website. So you can show 12 more lines. So these are the color codes you can use. You can see the color code. Oh, make I just go back to where would they come from. So these are color codes like this. But you can go into this thing and check more color code too. But these are color codes. Yeah, so you can, I just showed you that you can Google it and get this thing. They make sense color code. I think I'll try to show for there. So these are different color codes that we can have. This one is blue. Then this one is the X code for it. Then we have RGBX code. So maybe we just run this one like this. So you can see the different colors that we have because of this hash now. But this thing we say when you dey write time, you no go know the color wey you dey use. The only one we are known are the 0000. That's like 6 zeros. 1, 2, 3, 4, 5, 6. If you run this one, you go give me black. And the only one we are known for head with that. Others are not known. But if you are good with this thing, you can cram it, yeah. But you don't necessarily need to cram. You can just go and look for, let's say, what's it called? Let's look for okay, green hash code. So we look for that, it will give us the hash code for green. So and now be this is the hash code for green. So we can just do that like that. Okay, if I come here and do, you can see this is the green hash code. So maybe we just continue like that. So let's move on from there like that. So then the line thing. So we can have line width. So we can set different line width 0.25, 0.5, 1, 2. The line width is just by default it is 1. So you can make it thinner, like make it thin more. Then you can make it fatter. So like times 2 like that. So you can use line width completely, or you can just do LW equals this. Then line style. You can use line style or LS. So the line style is all those dash dash, style dash, and the likes like that. So now different line style where we get with this one. Then okay, we mentioned line width, line style, line color, which other thing. Then markers. Now the plus circle, that's the shaded circle. Then we have this S, that's solid. Then we have that space, sorry, I said solid, it's a space. Then we have the L, which is space length and the likes like that. So you can start experimenting with each of them. Now I just put everything for here. You can see how the thing just look for here like this.
Fine.
If fine for your eye, no fine for here. This thing is just showing you the different lines. For example, the first one here is the 0.25. You can see it's very thin. Then we have 0.5. Then we have 1. We have 2. Then we come here. Then we did line width equals 3 all through. If you notice from here upwards, the line width increased to 3. Then we now add, okay, line star. Now we can't change them to dash dash. So the line, you can see the dash. Then we have the dash dash. Okay, sorry, we have the dash. We have the dash dot, and this is the dash dot. Then we have the dot dot. This is the dot dot. Then we have the, which other one again? Then we have, which one again? Then we have the styles that we can, the markers. We have the plus. This is a plus. Where is it? This is a plus. Then we have the circle. I told you this is a shaded circle. This is a circle. Then we have the square. This is a square. Then we have this 1. So this one, if you notice, there is like 1 inside it. You look at where you go see like 1 inside it. Then we have the circle. Then the square. Then we are now having mark size to be 2. You can see the 2 is smaller. We have the mark size to be 4. The 4 is a bit bigger than the 2. Then we have the mark size to be 8. It's like the radius. So we have the 8 to be a bit big. Then we have the mark size to be 8. The 8 is like now like the length of the square. Now why you see them like this. Then we now give the square again. We can't say mark face color equals yellow. That's the actual color. Then we have the margin red. Then the mark ridge color green. That is the color of the color of the edges to be green. Then the thickness of the edge is 3. Now everything we get for here. So hope you get everything I explained for there. I know everything I explained and like nonsense. But everything we I explained there here, if you just read them and check again. Then we have plot range. So we can configure the range of our axis, set y limit, set x limit, the method of the axis object, that's axis tight, can for automatically getting the tightly fitted axis. So what we are just saying here is, okay, you can set our x limit, like, okay, our plot now, we don't want you to exceed, we want you to start from this place and end here. We don't want you to exceed this point. So now waiting with the use for the x limit with that. So if you see here now, we did tight, then we did x limit here. So we said our plot should start from 0 to 60. Then for the x-axis start from 2 to 5. So we plot this now. If you notice what's going on here, with the first one plot the actual thing, and that's this. You see, start from 0 and ended at 5.
Yeah.
Then the second one has x limit. No, the second one just has tight. This is it. It has tight. So here it is. It's just. So
what's like, okay.
So you don't get them like.
So what's the point of this tight?
The tight. Okay. Make I read down for you again. Or axis tight, automatically getting tightly fitted axis range. Like, okay, had it been this thing, no, how do I put it now? If this our plot, like fit into the plot we're supposed to get. Like if fit into the plot we're supposed to get. This one and this one might not really make any look like there's any difference now. But had it been like we have a plot that is supposed to be this wide, I want it to fit into something like this box, and we give it this tight. It will automatically give it that range that it should not exceed the length of this place, but all the numbers will be occupied in this range.
Yeah, I guess.
But this one now, the x limit give us 2 to 5, so it can only start from 2 and end at 5. So this other part from here now, if you want from here to here, don't disappear. You see saying start from 2 here. So from here now like saying start from here and then end here. You get them? So now it's happen for here like that. So we have special plot type now. This is where the actual interesting stuff start. All this one we will do since one na syntax. So here we start the actual plotting. So this plot is just like scatter plot now. So we want to do scatter plot. we will do scatter plot a lot. You see say this one no get line inside it, just I think we put plot here. Let me just put plot. If I put plot here now, say na line show us, but when I change am to scatter will just indicate the point of each of those x and y.
But it will not plot it here, I get.
It will not give a line. So here is okay. We created another range. Then want to plot histogram. You can see our histogram now. So this is how to plot histogram. Just put plt.hist.
But this histogram no sweet though.
Now the range where we give them now. Right. Let me change it to 50. You like this one?
Yeah, fair enough. Yeah, no problem.
Make a change it back to 100. So that's on that. The random normal. So we just generated numbers here. Then we now want to if you notice we generated a set of random numbers here. Oh, what am I saying? We generated a set of numbers from the normal distribution here. Then we are now so we're having different numbers. We're having for range 1 to 4. So we're having 4 different standard deviations. So we are generating like 4 lists like that. So we come here, you can see, okay, now 3 we actually, range 1 to 4. So we have 1, 2, 3. We won't pick 4. That's why we get 4 this thing with that. So we are generating 3 set of numbers with standard deviation to be 1, 2, and 3. Then because our standard deviation is down, if you notice our standard deviation is 1 here, if you notice the thing no really pass this thing. Then we have 2 here, then we have 3. Then we now have outliers. Outliers are those ones outside this range. So this is how to create box plot. Box plot is very simple. If I say patch artist equals false income, me myself they try something here. You can see what happened there. This thing no shade down. If I change them back to 2, let me change it back to 2 so you can see in shade down. So if I say this one to false, I just try make you see say if you change this thing wey dey inside the thing here, you see how the thing change the vertical to horizontal. So vertical equals to back, so you can have it back like this. So you get am like this.
Yeah.
You get everything we will do. So if I give you assignment, you go do am. No, I go send you assignment this night. I go
send you the assignment I don't do. You never mark any of them.
You sure you don't send them? You no send me the result too. You no finish am now. Sure you finish am now. Don't check am now.